All right, hello everyone. Honeymoon day 2. We are going to take a look at one of the problems that you guys were doing last night. We're going to look at 15. I think 15 and 17 were probably a little bit tricky because they don't have a value for b. They don't have something that's attached to an x. So let me write down 15, and then I'm hoping that will help you with 17 as well. So 15 is x squared plus 3. So just to recap, remember this is our standard form, ax squared plus bx plus c. So what we've got going on over here in this equation, there's technically a 1 attached to the x squared, and that's your value of a. There's nothing, no x anywhere in sight, so here our value of b is 0, and then this constant right here is c. So that's a little bit tricky when you're working on that, but just know that if you're missing a term at all, it's just 0. So let's set everything up. So start with our axis of symmetry. So we've got x equals, remember the formula is negative b over 2a. So this is what makes this a little bit tricky. You're like, well, b, I don't have a b. B would be 0. So I have negative 0, technically, and then over 2 times a, which remember is just 1. So negative 0, it's just 0. And then over 2, so 0 divided by anything, as long as it's not 0, gives you 0. So that's the axis of symmetry. So what I first want to do is I'm going to set up a little xy table. The first value I'm going to plug in is the 0. Okay, so if I plug in 0, because that's my axis of symmetry, plug it into the equation, I get 0 squared plus 3, which is 3. All right, so here's what I've got. I'm going to set up my graph so far. So my axis of symmetry is 0, which is also known as my y-axis. All right, so your axis of symmetry and the y-axis are one and the same. And your vertex is right here at 3. Okay, so these ones were a little bit tricky. Hopefully you were able to look some things up in the book. What you do now, because now this is also your y-intercepts. We have a vertex, we have a y-intercept. They turned out to be actually the very same point. So what you're going to want to do if this situation ever arises again is just plug in another value. So pick 1 and plug in 1. So if we plug 1 in, we get 1 squared plus 3. So 1 squared is 1 plus 3 gives you 4. So I would just plot my next point at 4. And then I would use this symmetry to say, all right, well, if I plug in the point on the opposite side, I would get the exact same y value. And then I can connect them using a smooth curve. All right, so that one looks something like that. Hopefully that helps you with number 17 as well. Those ones are a little tricky when the vertex and the y-intercept are the same. All right, so let's dive into what we are picking up with today. So we've got maximum and minimum values. So this is all kind of related to the vertex. Like I told you guys before, maximum and minimum, the vertex is either the max or the min depending on the shape of the graph, whether it's upside down or right side up. So we've got the standard form again. Let me just write it down. So ax squared plus bx plus c. It either opens upward and then it has a minimum value. So opens upward like this and has a minimum value if a is greater than 0. So if this number right here, a, that's attached to the x squared, if that's something positive, then your graph is going to open upward like this and it's going to have a minimum. So that is a minimum value. The graph is going to look like this. It's going to open downward and have a maximum if a is something less than 0. So again, that point is a max. So let me just show you a couple of examples. So once you've got that written down, I'm going to flip back to what we did on this page and on the previous page. So if we look at example 2, a was negative, the graph was flipped upside down, the vertex is a maximum. If we look on the previous page, part A was negative, the graph is upside down, the vertex is a maximum. Here, a is positive, the graph is right side up, and the vertex is a minimum. So we can see just a couple of examples of that. So that is what we know about the vertex being either the maximum or minimum values. So we want to take a look at this next example and then talk about its max or its minimum values. So determine whether the function has a maximum or a minimum value. Well, what I do is I look at this value right here. I have a positive number in front of the x squared, so that means that a is positive, which is what I have here. So if a is positive, that means the graph is going to open upwards like this, which means that my vertex is going to be a minimum. So the answer that I would give here is minimum. I am going to have a minimum value, and again, that's because a is positive, which means my graph opens upward. All right, so then state the minimum value. So the minimum value, the value itself, is the y-coordinate. the actual value. So state the maximum or minimum value. What I do is I start by setting up the vertex. So x equals negative b over 2a. I'm going to plug it in. So negative b would be a negative 24, which of course is a positive 24. And then over 2a would be 2 times 4, which is 8. So the x-coordinate of the vertex is 3. So I'm going to get my minimum value when x equals 3, but that doesn't tell me the minimum value. So what I need to do is I need to plug it back into my function. So I want to take the function and I want to plug in 3. That's what this notation means. So let's write that down. So 4, and then I plug in 3 squared minus 24 times 3, and then plus 11. So remember, again, this notation f of 3 means you're taking the function that you have up above, f of x, and you're plugging in 3 for x. So let's plug that right into our calculator. So this is, sorry, that's the same screen I had from yesterday. So 4 and then 3 squared minus 24 times 3 plus 11. So what I get is a negative 25. So that's the answer that I'm looking for. That is the minimum value. So if you were to graph this whole parabola, the very lowest point on it would be a negative 25. So we can use that to state the domain and range of the function. So let me just show you a quick sketch. This is not necessary for this part, but I think it'll help us get a visual so we can answer questions about the domain and range. So what I have is I know that when x is 3, so let's start with that, 1, 2, 3, my y value is negative 25. So let's scale down by negative 5, 10, 15, 20, 25. So that's my vertex, which means that this is my axis of symmetry. Remember, the vertex always falls on the axis of symmetry. So my parabola is going to be perfectly symmetric around that point. Now, I'm just doing this for a sketch. I'm just doing it to help come up with the domain and range, so this doesn't need to be a perfect graph, but I do know that because the 4 is positive, it opens upward. So all I need to know is that this opens up and down. It's going to look something like this. Okay, so we can use that, now that we've got a sketch in front of us, we can use that to answer the domain and range. So domain, remember from previous chapters, is all of the possible x values, and then the range is all of the y values that you get when you plug in any x value you want. So the domain for any sort of continuous function like this is going to be all reals. I'm sure you guys remember that from chapter 2. We talked about the fact that the domain is usually just all reals. I can plug in anything I want. If you look at this equation right here, I can plug in any x value, positive, negative, decimals, fractions, whatever, anything I want. So I get all reals for the domain. Now the range are the resulting y values. So if we look at this, these arrows show that my y values just keep going up and up and up. It's just going to go like this, just higher, farther to the left, farther to the right. But if we look at this point right here, I have a minimum value. The minimum value means my graph is never, ever, ever going to go any lower than that value. I can go higher than that value. I can go as high as I want, but I'm never going to go lower than that value. So I say that my y values can be anything greater than or equal to a negative 25. Negative 25 is the lowest I can go, and then it can be anything above that. All right, so that's my range. If I had an upside down function, then it would be anything less than or equal to the maximum value, because that would be the max. But if I have a min, I can be anything higher than that minimum value, which is why I set this up like that. Okay, so let's flip over. I believe we have a story problem to take a look at. Okay, so if we're reading through, this is actually the only other example, and then you guys will have plenty of time to look through some of these max and min problems and story problems. So example 4, a souvenir shop sells about 200 coffee mugs each month for $6 each. The shop owner estimates that for each 50-cent increase in the price, he will sell about 10 fewer coffee mugs per month. So these ones are a little tricky. I'm going to go through it nice and slowly. We need to set up our variables and do all sorts of things like that. So we're trying to figure out how much he should charge to maximize the monthly income. So we always start with variables. Anytime that we have story problems that we're trying to work through, we always start with variables. So there are two things. Let's talk about P. So P is going to be the price. Okay, and then the amount would be how much he sells. So 2 variables there, the price that he's going to charge and then the amount that he sells. So this is all going to come together into a new equation here. So we've got this overall price that's going to maximize the monthly income. So P for price and then A for amount. So he sells about 200 coffee mugs right now. All right, so what we're trying to find out is to maximize the monthly income. So let's stick with income here. So I equals, and then we're going to start putting everything together here. So if we say, let's do X. So X is going to be the number of price increases. And that's actually going to be our most important variable here. So now normally the income would just be the price and then times how many mugs he's selling. But now the price is going to be affected by the number of price increases, and the amount he sells is also going to be affected by the number of price increases. So if we start with the price, so income equals, so the price, he starts with $6 each, okay? So he starts with $6 each, and then he's going to increase 50 cents. So $6 plus 50 cents per price increase, okay? Because remember, X represents the number of price increases. So if there's only one price increase, it'd be $6 plus 50 cents. If there were 2 price increases, it'd be $6 plus $1. If there were 3 price increases, it would be $6 plus $1.50. So that's going to give us the new price. And then there's the amount. So the amount that he's going to sell is also going to be affected by the number of price increases. So originally, he sells 200 mugs each month, but he's going to sell 10 fewer coffee mugs per month with each price increase. So 200, but then minus 10 mugs for every price increase. So if he increases once, he's going to go from 200 down to 190. If he increases twice, he's going to go from 200 down to 180. If he increases 3 times, he's going to go from 200 down to 170. So this is, again, the price per mug, and then this is the amount of mugs that he's going to sell per month. So what I do first, if you guys remember foiling, it's a wonderful thing. I am going to FOIL this whole thing out and get my new equation. So first I multiply 6 times 200, and that gives me 1,200. And then I do the outside. I multiply 6 times negative 10x. That gives me negative 60 times x. Then I do the inside. 50 or 0.5, which is half, x times 200. Half of 200 is 100, x. And then I do the last. 0.5x times negative 10x. Half of negative 10 is negative 5. And then I have x squared. All right, so let's simplify that up, get one final equation here. I'm going to put it back in standard form, which means my x squared term comes first. Then I have a negative 60 and a positive 100. I can combine like terms to a positive 40x, and then I have 1,200. Okay, so that's my equation. That is my income equation. I know that because this value is negative, that I'm going to have like an upside down parabola like that. So I'm trying to find the maximum. I'm trying to find the point where the price increase would be worth it without selling too few number of mugs. So this is my value here. I'm trying to maximize the monthly income. So with these, the hard part is setting up the equation. The next part is to find the vertex and then figure out what the maximum value is. So the vertex is, the x value is negative b over 2a. So negative b would be negative 40, and then over negative 5 times 2. So that would be a negative 10. So I get this, I come up with 4. So this tells me that x should be 4. That would be ideal. That would maximize our income. And so that means 4 price increases. So if I do 4 price increases, let's see what I get. I actually want to plug it back into this version right here, just because I think that one makes more sense in the context of the problem. So the income equals, if he starts with $6 plus, and then if he does 4 price increases, he's going up 50 cents, $1, $1.50, $2. So he's going up $2. That's what I get by plugging in 4 right here for x. And then he started by selling 200 of them, but then every time he went up a price, he he lost 10 mugs per month. So he lost 10 mugs, 20 mugs, 30 mugs, 40 mugs. So we're going to subtract 400. So he is selling them for $8 a piece, and he is selling 160 of them. So if we plug that in, 8 times 160 gives us $1,280. So that is how he can maximize the price, is by going up in price 4 different times. So that would be the maximum price. Oops, I guess we were looking for something slightly different. Sorry, the maximum monthly income, that would be the $1,280. Let's back up to what we were supposed to answer here. How much should the owner charge for each mug? Well, the amount that he should charge for the mug would be $8. That's this price right here. So to answer part A, let's make a little note here. To answer part A, the amount he should charge would be $8. And then when I plug this all in, what I got for part B was $1,280. All right, so again, your homework is going to be some of these max and min problems as well as a couple of story problems. So while you're in class with your partners, you might want to take a look at the story problems first, just because they might be more difficult to work on your own at home. All right, good luck.